Sing for Science is made possible in part by a grant from Science Sandbox, an initiative of the Simons Foundation. Today's episode was hosted by the MIT Museum in Cambridge, Massachusetts, and recorded in front of a live audience as part of an ongoing collaboration with Sing for Science. For more information about the MIT Museum and future live events, please visit mitmuseum.mit.edu. Be sure to check out our other episodes, and please enjoy the show.
I have this great-great-uncle who worked on the atomic bomb. He got a Nobel Prize in physics and a place in this song. And I bet there were no windows and no women in the room when they applied themselves to the pure science of yeah, messing with the atom is the highest form of blasphemy. Whether you are making weapons or simply electricity, someone fashioned me a puppet. I have been called to engage with the maniacal heretics of the nuclear age.
Welcome to Sing for Science, the show where musicians and scientists talk about music and science. I'm your host, Matt White. Each week we'll talk about a song by our guest artist and how it connects with our guest scientist's area of expertise. Today we'll be speaking with iconic singer-songwriter and pioneering independent recording artist Ani DiFranco. Ani's prolific career includes the release of over 20 recorded albums on Righteous Babe Records, the independent label she started in 1989. Her 2008 song, The Atom, is a reverent ode to nature's smallest building blocks and also a scathing rebuke of the atomic age. Also joining us is Harvard University physics professor Dr. Melissa Franklin. Among Dr. Franklin's many distinctions are her contributions to the discovery of two elementary particles and having become the first woman to receive tenure in Harvard's physics department. Melissa is an experimental physicist and as such has devoted much of her career to working with particle detectors at the Fermi Lab in Chicago and the Large Hadron Collider in Switzerland to better understand the smallest known elements of matter. The title of this week's episode on the podcast is The Atom, Subatomic Phenomena According to Quantum Physics. Hello, Ani and Melissa. Thanks for coming on the show.
Hey, Matt. Thank you.
So this song that we just heard, it strikes me kind of as both hymn, song of praise, but also protest song. So which of the two provided the initial inspiration?
I guess protest. Yeah, there's a lot of politics in that song, as many of my songs. And a lot of pseudoscience I was just thinking, listening, that this is kind of like my biggest nightmare because I have so much pseudoscience in my tunes, and here I am probably surrounded by fact checkers and no way betters.
Actually, there's not a lot of pseudoscience in it. It's pretty good. I tried to find some holes.
Oh, good. Okay. Okay.
But
Step one, not
except maybe
holes.
your great uncle. I don't know that. Maybe
right.
That's
okay,
not. Maybe that's not true.
Well, great uncle is a little fudge, but yes, I do have a forebear who worked on the Manhattan Project and got a Nobel Prize. And yeah, I guess at the heart of that song is just the feeling that, I mean, I don't know. I do want to know what you think about this, but that science being so left-brained, that's the driver of this hyper-pursuit, logical pursuit that leads us to all these grand new territories. But the sort of other half of our consciousness is often not as engaged. The feeling, the presence, that we start following these paths into science and we become mono-focused and we can lose sight of things like, oh, should we be constructing this bomb? Should we be making electricity this way, with radioactive waste being the byproduct, just the sort of stepping back awareness that can get lost in the scientific process. I guess that's what's at the heart of that song.
Oh, really? Are you sure?
I mean,
Are you sure?
I don't know. You tell me.
Because
What do you
there's this
hear?
there's this refrain that you say, which is, "Let us now bow our heads in prayer at the magnificent consciousness incarnate there." I can't parse that exactly. What consciousness are you saying? That you're saying that consciousness comes from atoms, or are you saying the consciousness of knowing what you're doing with atoms?
Okay, here comes more folk singer pseudoscience. Okay, I think what I'm saying is that I feel like consciousness is born of relationship. Like, that's how I sense it. Which is not to say that, I think that I believe in sort of unified theory, that we're all one thing, but that being in relationship with ourselves is how we come alive. How we exist really is when we separate into two different things, the positive and the negative, and we start swirling around each other, or the up and the down, and the this and the that.
The yin and the yang.
The yin and the yang. I may not be the first to have imagined this.
Yeah. Well, so scientists do actually have some feelings, and they, I've heard, but also a lot of the people who are in the Manhattan Project really had ethical problems with it. So I understand that scientists should think more about what they're doing. Also engineers, programmers, everyone.
Well, which of those lyrics most resonate with your experience working as an experimental physicist?
The part where there's no women in the room. Like, I was thinking of the Manhattan Project, there were women scientists, but they were asked to just come for a few days and do their part and leave. But it is always a weird feeling, especially when you see a group of physicists going to lunch who are all men. And then you think that's very weird. So I always thought it would be nice to get all the women physicists in the world here and just have them walk to lunch. And just have, record that.
What do you feed them? These women physicists. Yeah. In that song, I use the word women as shorthand for feeling and awareness, like emotional engagement. And I know that is not just the providence of women, and there's masculine and feminine in each of us. And so again, that's it's a songwriting shorthand. But,
Yes.
Literally, yes, of course, I'm talking about the exclusion of women in so many fields and areas in this world, but also the exclusion of that part of our human sensibility that feels and cares.
But you know that women are constantly being criticized for instance, falling in love with the black hole they're looking for. Jonathan Lethem wrote a great novel about a woman who wanted to have sex with the black hole that she found.
Oh boy.
Oh my.
There's always that interpretation. Of course, scientists, women don't want to have sex at all, really. But no, I was going to say, science is a lot about this, especially physics, about the study of symmetries. So it's interesting that everything you've said so far this morning is all about asymmetries. We find those very interesting. In fact, that's all we do. And so this left-right brain that you suggested, can you feel it
when I'm doing my thing?
Yeah.
Well, I guess I do, in that my best songwriting moments are when, and I think it's something, again, generalizations, but I think my right brain really opens itself up. I go into a sort of a trance, it's sort of hours go by and then I look up and I don't know what happened, but there's a song, so I'm not thinking, and I feel like the antenna goes up and things come through. But then there's also a lot of songwriting moments for me that involve the other side of my nature, where I'm trying to work out the problem of how to get from this part to that part, or how to rhyme this with that, or what should or the structure, and I'm moving. So I think there's a back and forth in what I do with my work, but I think that the most shining moments come when I'm doing the least thinking.
So what you described is that going into that place and coming out later. It's exactly what happens in science. You go down into the pit, it's a place, and many hours later you come out, and it isn't all logical thinking. So you might be more like us than you think, or I might not be a scientist. I might be
Well, what's an instance of that, working as an experimental physicist?
literally, what's exciting about being an experimental physicist is not knowing whether it's night or day, like losing that sense of what's happening. You're so involved with what you're doing, but it's not an involvement that is just that you're imagining, like just constant, equations being solved in your brain. It's something where you're pulling back and you're trying to solve a problem without trying to solve any particular piece of it, which I think is the same as a song, right?
Yeah, I do understand that whenever ground is being broken, there is a very dynamic interaction happening. But when I look at some of the outcomes, like nuclear reactors and nuclear bombs, and I think, okay, something essential got lost along the way.
That's a good point.
Working with particle detectors more on the creation of knowledge side, right? Rather than like going for something that's insanely destructive.
No, that's right. I mean, what's interesting about what you say is that, if you ask young scientists today, would they take money from the military? What is their ethics? They haven't necessarily thought it through completely, and I think it might be a good idea, is what you're saying.
Yeah, like with this genetics pioneering that's happening now, and end games and outcomes, I think really have to be center in order to guide the course. But sometimes I think just the pursuit of knowledge or advancing can be very captivating. Yeah, I mean, it's funny to sit here and be springboarding from that song because I sound anti that pursuit maybe in this song.
No, I don't think so, because the entire first half is reverent, right? In praise of the building blocks. And this is something, Melissa, I want to ask, like, I've watched some footage of you working at CERN and actually looking at the data and seeing what it is to detect a particle. And I just want to understand nuts and bolts, like how do you know when you're looking at a photon or an electron? What does that look like? How is it represented?
Well, you don't know on a particle by particle basis. It's just statistically you would know. But mostly you look at objects that you reconstruct. So a photon, maybe because it leaves a certain kind of track, or no track because it's not charged, and it interacts and it leaves a certain amount of energy in the detector. So you look at sort of energy deposits all over your detector that surrounds your collision, energy deposits and ionization trails. And then you try and reconstruct it. So,
Okay.
but on an event-by-event basis, you don't know exactly what's happening. It's only when you put it all together. But I was thinking from this song that you were sort of imagining that maybe the new group of people who might have worked on the Manhattan Project before should work on climate change.
What I think this song is sort of about is I feel like we should all be reverent to this design that seems exponentially echoed everywhere you look, and not be the dudes with the chainsaw that go and cut down the redwood just to see what it looks like on the inside. That we should approach these things like the atom as we approach God. To me, that's what I'm saying, is that's where I see God. And that coming with that mindset to the study of it might help us with these outcomes.
Can you tell me more about the dude with the redwood?
I was just saying that our curiosity should not be at the expense of respect and honoring consciousness, which I think is deeply embodied in a 1,000-year-old tree. And I also feel deeply embodied in every atom, that there's something that we can learn about the nature of consciousness from the structure, the fundamental structure. I talk about, it's it seems that you can look at the cosmos and you see that same type of design. Again, I'm being poetic with it, and that we should think very long and hard about how we manipulate that and the amount of deference we bring.
So imagine that climate change, which is a problem, could be solved with some technical things. Let's just imagine that's true. But there was some danger that doing those things, doing those fixes, would completely screw up the world. Would you do them? Would you try or not try?
No, I would not. I would, in fact, all of the sort of technological fixes for climate change, I think, no. It's that we have to back up and stop making the problem, not assume that the problem shall continue, and we need to design our way through it. That, again, like the absence of consciousness, that yes, we've designed these ways to go faster, harder, longer, but should we, actually, yeah.
So you don't want to go to the moon if someone
No.
offered you don't want to go to the moon, or you don't even want to go to space.
Yeah, it's funny, we were just on the bus talking about it the other night. Whitey's on the moon, at some point I do get off the boat, even certainly when it comes to making colonies in space for when the Earth is uninhabitable, or making war in space, or it's that losing a fundamental perspective of what is helping and what is hindering.
Okay, so just one more question. I'm sorry.
Please.
Yeah.
I mean, at some point, these people need to leave with an understanding of quantum physics.
Oh.
So.
Sorry.
But
No,
with that said,
this is just what I'm interested
as you were.
in. Not sorry.
Yeah.
No, it's so late in the climate change story that not just stopping doing everything isn't really going to solve it. So I was just wondering whether, we could use atoms to make nuclear power plants again, which is something that you may think is a good thing now.
No, I don't. Actually,
Okay.
Nuclear waste, I think, is never, ever going to be a good thing. Or it's the idea that nuclear energy is green, to me, seems incredibly ludicrous. It's sort of like, sorry, my analogies are maybe more diversions, but, democracy, we've never tried it. Like, let's all vote, and then let's see if our democracy's broken. If we turn off the tap of the waste and the emissions and the pollution, and we've been told so many times over, the brain cannot regenerate itself, this is irreparable, but you can actually heal yourself from stage 4 cancer. Amazing things can happen within our bodies, and I think the pandemic offered us a tiny glimpse of what if we just turned it down? Oh, instant clearer skies. The amount that the Earth could repair itself is completely unexplored. So I think step one, rather than continue polluting and exploiting the Earth, like, what if we just stopped? I bet the Earth would amaze us with its response. We won't know, of course, until we try.
I thought we should talk about socks for a while. Would you like to talk about socks? The reason I wanted to talk about socks is because I wanted to talk about atoms again. There's a huge thing that's not going to solve climate change, unfortunately, in physics, which is quantum information, using quantum systems to make computers. Have you heard about that?
No.
Who knows what we're going to do with them? But if you're interested in atom, maybe for your next song, you could talk about entangled atoms, which is something like your idea of consciousness in a way. So you have one atom, and then, of course, you're splitting atoms in this song. But if you have two atoms, or two things, you can put them in an entangled state. And this guy, John Bell, who came up with a lot of the questions and answers about how you entangle quantum mechanical things, told a story about Mr. Bartelsman. Mr. Bartelsman was colorblind, and his husband was kind of a joker, and also did the laundry. So he would always put one pink sock and one blue sock together when he did the laundry. So since Mr. Bartelsman was colorblind, he couldn't tell. But since everybody knew the joke, they would know that if they saw the left foot of Mr. Bartlesman and it was pink, they would know there would be a blue sock on the other side.
Mm.
So this is a sense in which you can say, oh, they're linked in some way, they're correlated, and is that what entanglement is? Does that make sense?
I'm with you so far.
Entanglement of a state means that you can't describe correctly the behavior of one part without knowing the other parts. So in this way, the two socks are entangled.
Mm-hmm.
But in fact, I can actually describe one sock the whole way from the washing machine to the sock drawer to Mr. Bartlesman. So it's not really entangled. But it turns out that in physics, you can take two things, like atoms, you can put them close together. You know, in quantum mechanics, everything is probabilistic. So if they can have a direction, if one of these atoms can have a direction, and it can be either a direction up or a direction down, you don't know what it is, and you're not allowed to look at quantum mechanical particles.
And that's the way it spins.
So yeah, you can think of it as a bicycle wheel spinning, and it has some angular momentum. It can either up or it can be down. Think of a bicycle wheel going clockwise or counterclockwise. So the thing about quantum mechanical particles is you don't know whether it's up or down, and you won't know until you look at it. But if you put two of these particles together, okay, this is really cool, then they'll talk to each other in some way, or you can make them in a state like Mr. Bartlesman's husband did. You can make them in a state where there are always one blue and one pink sock. And then you can say, okay, I'm fine. Now I take one of them away, one of these atoms away, far away, like to the moon, and then when I look at this atom, when I actually measure it, I'll say, oh, it's up. And that means, even though I'm measuring this on the moon and light can't travel fast enough to get here, I know this one is down. Yeah, so the people were really weirded out because they thought, if you have an entangled state, you take one of the pieces of the entangled state away, and you measure something about it, now you know something about something here. And they thought that was action at a distance. Very weird. But it's kind of a very cool thing, and we're not sure how big entanglement is. Like, is everything entangled?
Mm-hmm.
And we're finding that this is a very useful way to make computers.
Well, it seems to me like this has kind of become this sci-fi catch-all. Like, well, if things can be connected light years apart, then who knows what other kind of ooga booga stuff is possible.
No. There's no ooga booga. I mean, information can't be transmitted faster than the speed of light. So that's the ooga booga stuff you're thinking about, right?
Well, it's interesting because I did this conversation with a computational psychologist, and I tried to bring in some hippie sensibility to the conversation because I'm like, I believe that we're all connected in some way that science can't measure. And he said, no, because nothing can go faster than the speed of light. So right there, you've got that you're going up against.
Wow, the psychologist said that. What do you think?
Bullshit.
Yeah. I'm with you.
Yeah. Everything entangled always, everywhere. Relationship. That's what it feels like to me. That we are nothing except in relationship. Does that make scientific sense in your...
I mean, I'm still worried about the going faster than the speed of light.
You
just can't get over that.
You gotta find that kid and give him an F. Yeah.
Well, the thing I find most comforting about any of this, and bringing us back to the Manhattan Project, is Richard Feynman, I think, said, if you think you understand quantum mechanics, you don't understand quantum mechanics. Is that bullshit?
Oh, okay. What Richard Feynman was saying is he wanted to think of quantum mechanics in how do we use it? How do we actually use it day to day? How does it work? We kind of know. We have all the equations. We know we can predict everything, right?
Mm-hmm.
And so, you can say you understand that part, but you don't really understand deeply why it's like this, I think. That's a different thing. Why is it equal probability to be up and down? Who knows? So I think we don't really understand it, but there's still lots of people thinking about it. And it's probably better just to think that you're on a distant planet. I think Feynman also said this. Just imagine you're on a distant planet and just figure out what the world is like there. And you don't have to worry, you don't have to worry that you have these ideas already about classical physics. This is just a quantum planet, and then it just seems very natural, and you don't have to worry anymore. So no worrying.
I want to set one reasonable goal.
Okay.
Because I've done multiple episodes about quantum physics, and I do not have the brain to understand it. So I would like to personally would like to leave with some understanding of what quantum computing is. If I can walk out of here with that, I can hold my head high in this entire campus.
I literally walked down the hall and to all my colleagues working in quantum computing, and I say, when you talk to public people on the radio, what do you say? And all of them said, I have no idea. I don't. It's so visual. So,
take a stab at it.
Okay. So it's about superpositions of states. So let's call it an electron to make it easy. It can be either a spin up or spin down.
Mm-hmm.
And an electron that I don't look at is in a superposition of up and down. Okay? Which is a different idea than having a bit on a normal computer, which is just either 1 or 0.
Mm-hmm.
So if I can use the fact that I can make a superposition of states, then I have a lot more power. So I now have 2 possibilities for every bit before, but now if I put them together in an entangled state, I have even more possibilities. So I can use the idea of superposition of quantum mechanical states to do calculations on the computer much, much, much faster.
Okay.
So that's basically the difference.
And will it take up less space? Like, could you store more memory on a smaller thing if you have more possibilities?
I think for memory, we're just going to use the old memory. You can make memory quantum mechanical, but right now we're making really, really small computers. Like, in the number of bits is 64.
Okay, I feel like we just got somewhere.
Yes.
So I want to stop before I get confused.
Okay, sorry. Goodbye.
I think it's really important that these conversations take us down all these desultory paths, because it's the importance of connecting. I think even sometimes, like, the more disparate and far apart, the better to have these conversations. So thank you so much, all of you, for coming. Thank you, Ani DiFranco and Dr. Melissa Franklin. Thank you so much. You can catch Ani on tour in January. Dates can be found at anidifranco.com/tour. For more information on Dr. Franklin's research, you can look up her published work at scholar.google.com. Sing for Science is co-produced by Talkhouse and made possible in part by a grant from Science Sandbox, an initiative of the Simons Foundation. Our music is by Panoram. Social media manager is Bailey Constas. Digital producer is Keenan Cush. And today's on-site recording engineer was Brandon Gauthier with Sovereign Candle. Special thanks to Brooke Ciardelli, Greg DeFrancis, Alethea Campbell, Ben Wahey, Martha Davis, Leah Talatinian, John Durant, Kate Harvey, Sheba, and Catherine Gunch for their help with today's show. If you liked today's episode, please tell a friend about the podcast and give us a review and some stars. For more information, go to singforscience.org and follow us on social media at Sing4Science. Thanks for listening.
Thank you.